All right, this is a video lesson where we're going to look at how to draw Bohr-Rutherford diagrams. And what we know is that the Bohr-Rutherford diagram, or the Bohr-Rutherford model, is a combination of what we know or have learned about the atom from Bohr and Rutherford. So Rutherford is the guy who discovered that there's a positively charged nucleus, and Bohr is the guy who discovered that electrons orbit the nucleus, kind of like how planets orbit our sun in the solar system. So when you are doing a video lesson, you want to make sure that you hit pause and copy the information that I write down into your notes as we move through the lesson. So what we know is that atoms of different elements differ by the number of protons, neutrons, and electrons. And you already know how to calculate the number of these subatomic particles in each type of atom by using information from the periodic table. Okay. What we're going to talk about today is that atoms also differ by where the electrons are found. So where their electrons are located is also different for all types of atoms. That is not how you spell also. Okay. So what we do is we use these Bohr-Rutherford diagrams to show where the electrons are located in different types of atoms. Okay, so not only do different types of atoms have different numbers of protons, neutrons, and electrons, but their electrons are located in different spots. So every single type of atom, so every single element has a unique electron arrangement. We're going to look at how to draw this electron arrangement for our types of atoms. But before we do that, I want you to hit pause and copy this down. All right, now that you have this copied down, let's look at an example. And we're going to look at, okay, so sorry. Now that you have this copied, make sure you have this copied, and then we're going to do an example. We're going to look at an example of a lithium atom. So when we draw our Bohr-Rutherford diagram, the first thing that we're going to do is we're going to draw the nucleus. So I'm going to do my different steps in different colors. So I'm going to do my nucleus, and I'm going to give myself lots of room, and you should too. I'm going to draw my nucleus, and my nucleus I want you to note is drawn as a solid. It's a solid ring. So the line is solid. This is important for later. Okay. Once you have the nucleus in your Bohr-Rutherford diagram, you're going to write the number of protons and neutrons in the nucleus. So when we're looking at lithium, we can calculate that lithium has 3 protons. So I'm going to write the number 3 followed by the symbol for protons. And lithium, we can calculate, has 4 neutrons. I'm going to write the number 4 followed by the symbol. So our second step for Bohr-Rutherford diagrams is to write the number of protons and neutrons in the nucleus. Okay, and remember that it is the number followed by the symbol. So our first step is to draw the nucleus as a solid ring. And then our second step is to put the number of protons and neutrons in our nucleus. The next thing that we need to do is add our electrons. And this is where it gets a little bit more tricky. Our electrons are found in orbits. Okay, now the orbits are actually called energy levels, and where the electron is depends on how much energy it has, but that's something that we don't really talk about too much until grade 11. But for us in our Bohr-Rutherford diagrams, we have to draw our orbits, and then we put the electrons in the orbits, except there are some rules that we have to follow. So the first thing that we're going to do is draw our first orbit. And our orbits get drawn as a hatched line. So the nucleus is a solid line, but our orbits are a hatched line. So I'm going to come up here and I'm going to go 3 orbits. They are a hatched line. And when we draw our orbits, we only draw what we need. And I'm going to explain what I mean in a minute. So only draw what is needed. After we start our orbits, we can fill in our electrons. That's our last step. The last step is to add our electrons. Now, lithium has 3 electrons. Our electrons, we just draw them as dots. And we draw them in or on the orbits or the energy levels. Okay. Now, our first orbit that I have drawn here, our first energy level can only hold 2 electrons. So I'm going to scroll up. So I'm going to say down here, say our first energy level can hold 2 electrons, and our electrons, they're both negatively charged. So they don't actually really like each other. Remember that objects with a similar charge repel. So the negatively charged electrons repel each other. So we're going to spread out these 2 electrons, and one is going to go at 12 o'clock. And one is going to go at 6 o'clock. So what I mean by this is that if you think about a clock face, I'm going to draw a clock face over here. If we think about a clock face, so if this is our clock face, that's a terrible clock face. If we think about our orbit being a clock face, 12 o'clock is up here, 6 o'clock is here, 3 o'clock is here, and 9 o'clock is here. So when we draw our 2 first electrons in the first energy level, we put 1 at 12 o'clock and 1 at 6 o'clock. Now, lithium has 3 electrons. Currently in our picture, there's only 2 electrons. So we have to add another orbit. Now, this goes back to what I said. You only draw what is needed. We filled the first orbit, the first energy level. So this means that we have to add another energy level so we have a spot for the other electron in our lithium. So then we draw another orbit, just like this. And this energy level, this second energy level, and all other energy levels after the first one for the purposes of our learning right now, can hold 8 electrons. So we're going to write that down first. Ooh, I'm out of space. Okay, I'm just going to keep going. I don't want to draw this in green. I want this to be in orange. Okay, so I'm going to say all other energy levels can hold 8 electrons, and they go at, this is important, 12, 6. Nope, that's a lie. They go at 12, 3, 6, and 9. So again, if we think about our clock face, when we fill our next orbit, our next energy levels, we fill them at 12, 3, 6, and 9. So I'm going to add my third electron, and it goes here at 12 o'clock. Okay. There's one other rule we have to talk about, and I'm going to write the rule down, and then I'm going to show you what I mean. So when we are filling all the other energy levels that can hold 8 electrons, eventually we're going to pair them up. It's important, though, that we fill every spot first before we pair them up. Fill every spot first with 1 electron before you pair them up. I'm going to show you with another example. But before I do that, I'm just going to zoom out so you can see the whole thing. I want you to hit pause and make sure you have this all copied. All right, let's do a couple examples and show you what I mean about by filling every spot first. All right, so our next example, we're going to do an example. We're going to do oxygen. So in order to draw our Bohr-Rutherford diagrams, we need to know the number of protons, neutrons, and electrons. So if we look at our periodic table, we can easily calculate, we can easily see that oxygen has 8 protons, 8 neutrons, and 8 electrons. So we're going to start our Bohr-Rutherford diagram for oxygen. We're going to draw our solid nucleus. We're going to add our protons, number followed by symbol. We're going to add our neutrons, number followed by symbol. And then we're going to add our electrons. So when we go to add our electrons, we have to draw our first orbit. Make sure you draw your orbit is a hatched line like this. And then we're going to start placing our electrons. In our first orbit, we know it can only hold 2. Oxygen has 8 electrons, so we know it's going to fill this energy level or this orbit. So we're going to put our electron here and here at 12 and 6 o'clock. So at this point, our diagram is only showing 2 of the 8 electrons. So we have to place 6 more. So we need to add another orbit. So we add another orbit. Remember, we only add this orbit or this energy level when we have electrons to put in it. So I have this. I have 6 more electrons that I have to place. This can hold 8. So I know that all my electrons are going to go in here. They go at 12, 3, 6, and 9 o'clock. But then I also told you that we fill every spot first with 1 electron before we pair it up. So when we go to fill, we're going to go 12, 3, 6, and 9. But now I have 6 of my electrons in my picture, but I need to put 2 more. So now that every spot at 12, 3, 6, and 9 has an electron, that's when I pair it up. So now I'm going to put a pair here for my 7th electron and one here for my 8th electron. So I can do a quick count. 1, 2, 3, 4, 5, 6, 7, 8. I have all my electrons and my diagram is done. Okay, we're going to do one more together. So in this example, we're going to do magnesium. And from our periodic table, we can calculate that magnesium has 12 protons, 12 neutrons, and 12 electrons. So I'm going to start my Bohr-Rutherford diagram. I'm going to draw my solid ring for my nucleus. I'm going to put my protons, number followed by symbol, and my neutrons, number followed by symbol. I'm going to draw an orbit, my first energy level. My first energy level is going to get filled. I have 12 electrons to go, and I have 2 in that first energy level, so I have 10 more I need to place. So I'm going to draw another orbit, hatched line, and I'm going to start filling. So 3 electrons, 4, 5, 6, 7, 8, 9, 10. At this point, I have 10 electrons, but I need 12, so I have to add another orbit. So I add another orbit, and I follow my rules, starting at 12, putting them by themselves first, 11, 12. Okay, so follow these steps for drawing your Bohr-Rutherford diagrams. Use the steps: solid nucleus, protons, neutrons in the nucleus, draw and fill an orbit, and only draw the orbit when you need it to put an electron in there. Okay, so you're going to do some practice of drawing some Bohr-Rutherford diagrams, and then we will work on some together in class.